We're using a Gaussian process regression model, a powerful tool for regression tasks, and specifically using the DotProduct kernel. Within it, this kernel is crucial because it defines how the model assesses the similarity between different data points. This is a multiple-choice question testing your understanding of how the DotProduct kernel functions and what assumptions it makes about the data. Let's examine each statement and figure out if it correctly describes the DotProduct kernel. This is absolutely true. The DotProduct kernel calculates similarity using the dot product of input vectors, showing it's designed for data where the relationship between inputs and output is well represented by their dot product. That's also correct. Because the kernel uses the inner product, I'm inferring a linear relationship. Think of it as a straight line between inputs and the target value it predicts. This one is false. While scaling can help some machine learning models, it's not a must-have for the DotProduct kernel. I don't need to explicitly scale features for it to work. Nope, this is wrong. The DotProduct kernel's linear nature makes it unsuitable for high-dimensional, complex, and nonlinear data. For this scenario, a more flexible kernel like an RBF kernel would be a better fit. Okay, let's select all the correct statements. I'm providing more information about the DotProduct kernel to support your understanding. We're using a Gaussianprocess model, a powerful tool for regression tasks, combined with a specific kernel called the DotProduct kernel. This kernel dictates how our model measures similarity between data points. Let's test your understanding of the DotProduct kernel within this Gaussian process regression framework. I'll give you some statements, and you'll decide which ones are true. I'm asking you to identify the correct properties of the DotProduct kernel when used in a Gaussianprocess model. This statement is true. The DotProduct kernel directly uses the dot product, the sum of the products of corresponding entries in two vectors, to assess how similar two data points are. If the dot product is the key factor determining your data's relationships, this is a great kernel choice. This statement is also true. Because the kernel's core operation is the linear dot product, it inherently assumes a linear relationship between your input data and the values you're trying to predict. This is false. While scaling your features can sometimes improve a model's performance or numerical stability, it's not a strict requirement for the DotProduct kernel. It'll still work without it. This statement is false. The DotProduct kernel is essentially linear. If you have complex, nonlinear data, you should pick a different, more flexible kernel. I think this statement is false. The DotProduct kernel only works well with data that has a simple, linear relationship between features and the target. When you have lots of features with complicated, nonlinear interactions, this kernel won't cut it. You'd need a kernel that can handle the curves and twists in the data. Think of it like trying to fit a straight line to a squiggly curve. It just won't work well. This is just the instruction for the multiple-choice question, telling you to pick all the true answers. This is the title introducing the multiple-choice question about the DotProduct kernel in Gaussian process regression, GPR. GPR uses kernels to model the relationships within data. These section headings guide you through how to solve the problem. They break the explanation into sections focused on understanding the question, describing the needed concepts, and providing a step-by-step approach. I'll explain the DotProduct kernel. Imagine you have two data points. The kernel calculates how similar they are by taking their dot product, a simple way to compare vectors. A larger dot product suggests greater similarity. This is all about understanding how similar 2 points are in a data space, and it's at the heart of how Gaussian process regression uses this kernel. The DotProduct kernel's magic is using the inner product, or dot product, to measure similarity between data points. It directly uses the result of this inner product calculation as a measure of how similar the data points are. It's a very direct and straightforward way to assess similarity, assuming that a larger dot product means greater similarity. Because the DotProduct kernel relies on the dot product, it inherently assumes that the relationship between the inputs and the target variable is linear. That is, the model implicitly assumes that the target value is a linear function of the inputs. It's not explicitly stated, but it's a consequence of how the kernel works. While feature scaling can be beneficial for many machine learning algorithms, it's not absolutely necessary for the DotProduct kernel to work correctly. The kernel's functionality isn't fundamentally dependent on the scale of features. However, I would always recommend considering scaling for numerical stability and possibly better performance. It's a good practice. I want to be clear, the DotProduct kernel is not ideal for complex scenarios. Its assumption of linearity makes it unsuitable when dealing with high-dimensional data where the relationships between features are complex and nonlinear. If you have this kind of data, consider other kernels that can capture nonlinearity better. We're using a Gaussian process, a powerful machine learning method, with a specific type of kernel called the DotProduct kernel. Think of a kernel as a function that measures how similar two data points are. The DotProduct kernel uses the dot product, a simple mathematical operation, to do this. I'm going to test your understanding of the DotProduct kernel's properties within Gaussian processes. Get ready for a multiple-choice question. Let's see how well you know the DotProduct kernel. This question checks whether you understand its behavior and what it assumes about your data. This statement is true. The DotProduct kernel directly uses the dot product of input data points. If the relationship between your input data and the target variable is best described by the dot product, then this kernel is perfect. This is also true. Because the DotProduct kernel's workings rely on the linear dot product, it naturally assumes a linear relationship between input features and what you're trying to predict. It's not designed to handle complex curves. This is false. While scaling your features can be helpful in many machine learning tasks and may improve numerical stability, the DotProduct kernel doesn't strictly require it. It works with or without it. This is false. The DotProduct kernel is a linear kernel. For high-dimensional data with complex relationships that aren't linear, you need a kernel that's better at capturing those nonlinear patterns, such as the radial basis function or RBF kernel. Remember, you need to choose all the statements that are correct. This emphasizes that you need a thorough understanding to get this question right. I'm using a Gaussian process regression model, a powerful tool for prediction, and I'm specifically using a type of kernel called the DotProduct kernel. Think of a kernel as a way to measure similarity between data points. I'm going to test your knowledge on this DotProduct kernel with a multiple-choice question. Get ready. This question asks you to identify the true statements about how the DotProduct kernel works. The DotProduct kernel works best when the relationship between your data's input features and the target value can be well represented by a simple dot product. Think of it as a way of measuring how much two vectors point in the same direction. This implies a linear relationship. Because the DotProduct kernel uses the dot product of the input features, it's essentially assuming that the relationship between the inputs and the outcome is a straight line, linear, not a curvy line, nonlinear. While scaling your data often helps machine learning models, it's not mandatory for the DotProduct kernel. It works with or without scaling, it's not strictly dependent on it. No, the DotProduct kernel does not handle complex relationships well. Its strength lies in simpler, linear relationships. High dimensions with nonlinearity would be better tackled with other kernels. Choose all the answers that are correct. Good luck.